mentioned this word before when we were creating our unit circle. You talked about it in Algebra 2. But then, can you remember what it is? A reference angle. What is a reference angle? Do you know?
Isn't it like the angle always from the x-axis?
That is exactly what it is. The angle away from the x-axis. Okay? So my definition up here is the acute angle formed by the terminal side of theta and the x-axis, which is exactly what Addie described. Okay? So if you want to write it how Addie described it, that's fine. If you want to write it the way that I have it up here, that's fine. We're going to notate it with a little prime, so like theta prime, so we can just notate it a little bit differently than the actual angle itself, but so that we know that they're related. Hi. Go for it.
Oh, this looks like fun.
Oh, it is.
You know what? That's
I should remind you, I should remind you that the reference angle is always positive. So no matter where you are, we're always going to measure it as a positive angle. Okay. So if you need a picture, you're all about the pictures. If this is theta, then this is theta. Okay. How far do you need to rotate to get to the x-axis? And remember, we're always going to measure it positively. Okay. How far away are we from the x-axis? And it's always going to be acute. Okay. So we're going to break this up into 2 different days. Okay. Today we're going to focus on all of the unit circle type problems that we would encounter. And then tomorrow we'll talk about all of the non-unit circle type problems. Okay? Which is why I made you do that unit circle quiz today, so it was in your head. Going back to that unit circle quiz, if either A, you did not get that filled out in the 5 minutes, or B, you did get it filled out, but you got some things mixed around, make sure you're looking at that just a little bit each day, so that that's in your head, so you can recall from memory a lot easier. Okay? All right. The x-axis, before I move forward. The x-axis, we are either at 0, pi, or 2 pi. Okay? 0, pi, 2 pi. Those are the only measurements that would matter when we're talking about a reference angle. Okay? Because we're always going back to that x-axis. Okay? So if I asked you to find the reference angle of 315 degrees, we're going to talk about degrees first. Okay? So in that case, we're 0, 180, and 360. Okay? First of all, 315 degrees is in which quadrant? Fourth. Okay? Having to say coordinate and quadrant, like in the same, it gets tricky. Okay? 315 degrees is in the 4th quadrant. How far away is it from the x-axis? 45. Its reference angle is 45 degrees. Okay? And since its reference angle is 45 degrees, then it has the same coordinate as 45 degrees. We just changed where the negative and positive go. 7 pi over 6. Draw it for me. 7 pi over 6. Draw that angle. Kaya, where's the terminal side of 7 pi over 6? Okay, the third quadrant. And since it's pi over 6, it's just barely, right? Okay. So how many radians are we from the x-axis? Okay. We are only pi over 6 away from the x-axis. Ooh, that was a terrible drawing. I'm really sorry. Just make it really thick. Okay. If you need the math behind it, we need to get back to pi. So 7 pi over 6 minus pi would be pi over 6. Okay. If you need that. Now, since the reference angle is pi over 6, then 7 pi over 6 has the same xy coordinate. However, in this case, since we're in the third quadrant, x is negative, y is negative. Okay? I'm really trying to reiterate the fact that if you know the 3 coordinates in the first quadrant, then you know them all. Okay? I'm just going to really hammer it in the tricks that we need to know. Okay? So, make sure your unit circles are not in sight. Okay? Let's practice evaluating before we start working backwards. Okay? So, cosine of 4 pi over 3. My suggestion, think about the coordinate at pi over 3. Think about which quadrant 4 pi over 3 is in, and then write down the x coordinate. And Miss Stock, which quadrant is 4 pi over 3 in? In the third. So that means cosine is going to be negative. And then the x-coordinate for any of the pi over 3's is going to be what, Dallas? 1/2. So we have negative 1/2. Okay. See how I didn't just think about the coordinate? Okay. You don't need to know 16 coordinates. You need to know a few and know how to translate them. Okay. Tangent of negative 210 degrees. Okay, we kind of talked about this last week. If it's not one of our normal angles, we can think about its coterminal angle. So somebody help me out. What is the coterminal angle for negative 210? What do you say? 150. Negative 210 plus 360 is 150. So let's think about the tangent of 150 degrees. Okay? Some of you, I hope, can do this without having to write the x and y coordinate down. Okay? We kind of talked about something over here. Okay? Or you can write the x and y coordinate down. What's the y coordinate at 150? And the x coordinate? Okay? If you know that the tangent of 30 is radical 3 over 3 and the tangent of 60 is radical 3, you wouldn't have to do the division here. Okay? It's going to be a positive or negative version of those every time. Okay? One more for good measure. At your pod, talk about what the coterminal angle is and then evaluate it. Guy, what's our coterminal angle here? 3 pi over 4. If we subtract 2 pi, we're at 3 pi over 4. Cosecant is the reciprocal of sine. Sine means we're thinking about the y value. What's the y value at 3 pi over 4? Emma Ralston, what's the y value at 3 pi over 4? Radical 2 over 2. So if we're talking about the cosecant, we're talking about the reciprocal. Radical 2. All right, now the fun part. Okay? We talked about these, and this is a lot like what your homework was the past few days, right? Okay. Now what I'm going to ask you to do is I'm going to ask you to think about something like this, okay? The cosine of theta equals 1/2, okay? The cosine of theta equals 1/2 at an infinite number of times. But I want you to think about one unit circle rotation, and I want us to identify any angles that we can in one rotation where the cosine of theta equals 1/2. So if you haven't already done so, write cosine of theta equals 1/2 on your paper so you know what you're answering. Okay? Well, we're talking about a cosine that's positive. Okay? Cosine is positive in both the first and the fourth quadrant. So there are two answers to this question. Okay? So in the first quadrant, the cosine is 1/2. Riley, where does that happen? Which angle measure? Where's cosine 1/2?
60.
Which one are you going with?
60.
60 degrees. Again, if you need the hand trick, right? 60 degrees are x coordinate. Radical 1 over 2. Okay? Now, let's also talk about that it's the same thing as pi over 3. Okay? We also have a positive cosine value in the fourth quadrant. Well, if we already talked about 60 degrees, let's just make that a fourth quadrant angle. What would it be? 300. Okay? Using that reference angle, right? We're 60 degrees away from 360. Or in radians, that would be what pi over 3? 5 pi over 3 when we want to be in the fourth quadrant. Okay? So you see how it's kind of like working backwards? We were trying to recall which angles have that particular ratio. Okay? That's all we're doing today. Okay? Write this one down. Cosecant is the reciprocal of what? Sine. So we're talking about, since it's positive, that's a positive radical 2, we're talking about a first quadrant angle and a second quadrant angle. When you see radical 2, you get kind of excited, I think. Sorry. The reciprocal of radical 2 is 1 over radical 2. We don't have that exactly on our paper, but we can rationalize it, right? Okay, the reciprocal of 1 over radical, the reciprocal of radical 2 is radical 2 over 2. Okay, so what degree measurement has a sine ratio of radical 2 over 2? Okay, Callie, what would that be in the first quadrant? 45 degrees. Or pi over 4. Okay? In the second quadrant, Nate, what would that angle be?
135.
135. How about in radians?
3 pi over 4.
Okay, this doesn't get any harder. Like, this is all your homework's gonna be tonight. Okay, like, this is it. Okay, so do this for me. At your table, come up with the angles both in degrees and radians from 0 to 360, 0 to 2 pi, where tangent of theta is undefined. Emily B, in degrees, where are we? Okay, Emily came up with 90 degrees and pi over 2. Do you agree? Is that the only place? Other Emily?
270.
Okay, and both of these coordinates, the x coordinate is 0. So when you do y divided by x, we have undefined. Okay? Sine of theta equals 0. That doesn't happen, does it? Are there only fractions over 2? It would not be the same. What, Riley?
Wouldn't it be 0 and 180?
Riley says, wouldn't it be 0 and 180? And yes, technically 360, right? Because 0 and 360 are the same. Okay? 0, 180, and 360, that is where the y coordinate is 0. Do you agree? Okay. What would the cosecant ratio be here? Say louder. Undefined. Okay. The reciprocal of 0 is undefined. Okay. All right. Last one. Okay, now here is where probably the more difficult part of the recall is going to happen when we have tangent and cotangent, okay? Now tangent and cotangent at any of the 45-degree angles, not a problem. It's always going to be 1 or negative 1, okay? But at the 30 and 60-degree angles, we have either the radical 3 or the radical 3 over 3, and if you don't memorize which one is which, you might have to draw up some fractions. Okay, so first of all, let's talk about that cotangent is positive. So which quadrants are we going to be coming from? 1 and 3. Okay, so now it's a matter of which x over y ratio is going to give us radical 3 over 1. Okay, so we have two choices, right? And some of you already know in your head what it's going to be, and that's fine. Write down your answers. For those of you who are iffy on how to come up with this, you have two choices. You have 1/2 over radical 3/2, or you have radical 3/2 over 1/2. Which one is going to reduce to radical 3? The first or the second one?
Second.
The second one. These two are going to cancel out, and we have radical 3 over 1. Okay? Yes.
Is it different because it's
Well, yeah, because we have x over y. So the tangent that's radical 3 over 3 is going to have the cotangent that's radical 3 because those would be reciprocals. So which x over y would be radical 3 over 2 1/2? Okay, so we are talking about an angle of 30 degrees or pi over 6. And like Max just asked about, okay, since the tangent of 30 degrees is radical 3 over 3, the cotangent is going to be the reciprocal, radical 3. Okay? And then in the third quadrant, which angles are we talking about? 210 and, whoops, 7 pi over 6.
Oh my god.
Okay, so this is what I need you to do. I am going to pass back your quizzes and give you the opportunity for the quiz reflections. But before I do that, I would like you to get out your unit circles and in your pod, ask each other 2 questions each. Okay? So everyone will answer 2 questions. Okay? So if there's 3 of you, I think you need to do it in a circle. If there's 4 of you, do partners. Okay? But say, something like this. Like, where is the cotangent? Blah, blah, blah. Where is the sine? Blah, blah, blah. But everybody answers 2 questions modeled like these 6 problems that we just did. Does that make sense? When you're asking, you can have your unit circle. When you're answering, try not to look at your unit circle. You have 5 minutes. All right, ask each other some questions.